So first assumption that we make in any beam, plate or cell is that these elements are thin. Thickness is very small compared to the other two dimensions. This is the first assumption that we make. Then only further we can proceed. If you make the first assumption, then we make that transverse normal, the straight line thickness, remains straight and normal to the mid-plane during deformation. Okay. Now if this remains straight, this is the horizontal plane and this is the transverse normal. So it always 90 degrees maintained. So if 90 degrees maintained, there is no shear strain. Shear strain is change of right angle. So there is no shear there. Then we also assume that thickness does not change. I am emphasizing this more for the students to understand. The thickness does not change means there is no normal strain. If you take 2 points in the thickness, they don't change. There is no change. So epsilon z is 0. So that is another. And one thing that we forget again, in order to simplify the three-dimensional Hooke's law. Hooke's law means there are 6 components of stresses and 6 components of strain. They are related to each other. But then if you don't make the last one, this assumption that I am telling you, it is a little, pain in the neck kind of thing. So we make assumption that these in-plane stresses, sigma x, sigma y and tau xy, which is in-plane stresses, these are dominant stresses in the plate. These are similarly in the beam, sigma x is a dominant stress, while transverse stress is a small quantity. So we can assume that transverse stress is small compared to other components of stresses. So similarly I have written it is small, tending to 0 means it is not 0, it is a small quantity, it is small compared to other stresses. And if you make this assumption, then the state of stress in a plate becomes a 2D. So from 3D Hooke's law, we get a 2D Hooke's law. So that simplifies the mathematical model. So these are the basic assumptions. Now these assumptions remain the same. It is the same for beam in one dimension. It is the same for shells if the plate becomes curved. Everything remains the same. So these are all classical. So this is what, transverse normal. In one of the interviews for a faculty position, I asked what are the assumptions in Euler-Bernoulli beam theory.